Hey, what's going on, guys? Mike against here. Last video we did some preparation in order to implement our parse FEN function, and this video finally it's about to come. So this stuff is known as the FEN string, which stands for Forsyth-Edwards notation, which is the standard way of representing chess positions via strings, basically. So first we go through the rank number 8, rank 7, 6, 5, 4, 3, 2, and so on. And then we have the side to move, castling rights here. So this castling rights, I'll describe and explain how to kind of how one can interpret this. So this dash stands for the absence of enpassant square, and I'm not sure regarding this parts like total move counts and half move clock or something like that, but we don't really need this last two, so we only need like side move and this castling rights and the enpassant square if available. So let me just one little more thing to consider. This numbers stands for the number of empty squares encountered within the row. So if I just try to paste some sort of another different position, which is known as a tricky position among the chess engine developers, and this is so tricky because it allows you to track the most bugs during writing your move generation logic, and also it's quite pretty good one to use to debug your parse FEN function as well. So this is the exact sort of a FEN that was supposed to be used in order to make our FEN parser. So you see, like, we got the rook, and then we got this 3 empty spaces, then we got a king, then we got a rook, then we got again 2 empty spaces followed by the rook, and so on. So just walking through all the available sort of ranks and files here. I'm not sure regarding the castling rights. Yeah, so the castling rights are standard, and the enpassant square is also standard. It is not available, but that's not a big deal really. So I just want to grab this FEN and go to my source file, and at the very beginning probably I would like to provide FEN positions for debug purposes, or let's say debugging or better even FEN debug positions like this. So I will define this starting position. So start position, and we'll provide this just right in a moment, and also this one called tricky position, and this would be equal to okay, like this, and also this should be the character pointer, and just to make sure that it's not gonna get it's not gonna smash the stack. I just want to create this arrays of characters to make sure they occupy and initialize some place in the random access memory in the computer. Oh, forget what I've just said. Just dislike to do here. And also I just want to make this initial board, so copy and paste this right over in here. So now let me try to open my terminal in the current working directory, and from the last video I got this compile and run command, so I just run this. Okay. It would be really strange if it just works out of the box. I have no idea what's kind of going on here. Oh, that's because I don't need these pointers. Yeah, just the pointers would be good if we had the array of strings, but as far as we have the only string, we don't really need those pointers. I'm sorry for this little miss here. Okay. Okay. So now we have our board been printed to the console, and it has been initialized, like hard-coded. So we say like this initial position was kind of hard-coded to our board. And the very first thing we need to do basically within the parse FEN function is actually to reset our board. So, but also it's nice to have the reset board function being separate. So I would like to define this. So let's say reset board function, and I can say void reset board, and here I just need to grab the loop that we did make use of in the print board, and we would be reusing this loop even further on within the parse FEN as well. Also, I need this part. Okay, so I'm doing literally the same. So I'm looping over the range of over the board ranks down, over the board ranks down over the board files. So just forgot to mention this loop over board files. By the way, let's put this commentary right into here. Okay, and if square is on board condition. So if square is actually on board, so yeah, before that just put all the closing curly braces. So here we need to say board indexed by the square, and what we do here actually reset current board square equals to 0 or to empty, right? So we already have this empty e, we have this e enumerated kind of variable like then in order to represent the 0. Okay, and yeah, this is it. So if I now call this reset board function and print board after, the pieces should have disappeared. Okay, so square not like this, square like this. Okay, so we got these pieces getting disappeared. Okay, so the next thing to consider, we can actually start to implement our parse FEN function. So void and parse FEN. This function would take the character pointer to the FEN string. Okay, and sorry, some layout issue here. Just forgetting to add this extra new line because it's better in C to make this like. Okay, so the very first thing to consider, we need to reset our board, and I just call this reset board function now within my parse FEN. So here let's parse FEN, and here I will use my tricky position variable that is the type of string right over in here. So this is the string that is being passed to our parse FEN function, which is quite pretty important. Okay, so yeah, hold my breath, trying to compile and run again. It runs. Okay, perfect. So now let me grab this loop one more time, and the following stuff needs a little bit more explanation, so I will walk through them. Okay, just to keep the indentation level okay pretty nicely here. Okay, even though C doesn't care regarding the indentations, well, like Python do. Okay, hold on a sec. What did I? No, this was actually right. This was right. So just the if statement. Okay, and here, yeah, so just the if statement. And here we don't need to reset anything, but instead we would be providing our logic right over in here. So the very first thing I would like to consider, actually, I want to print some debugging information. So now we will start making use of the data structures we've created. So the very first thing to consider, so every square we encounter, we can actually print say square, and this would be the type of I guess this would be a string. Okay, and what am I supposed to reference here? The square to coordinates, copy. So I am indexing the square to coordinates array by the current square, and this should print me every single square it encounters. So I just want to add some new lines here as well. New line. Okay, so we do you see, like, we loop over all the squares available, which is quite pretty nice. And what else to consider here? Also, let's print our current FEN character, and this would be already a character, so this stands for character, and we can say pointer to FEN, which we did pass to our parse FEN function here. So it now remains R because we didn't yet increment this, and the idea is as simple as far as we encounter a next square, we want to we want to increment our FEN pointer as well. So I'm using this word pointer, which might be a bit confusing for those of you who have no experience in C. So I guess, like, array indexing is quite pretty easy to understand. You say, like, if you have an array, you can index that by an index, and the pointer is quite pretty similar. So pointer is the memory address pointing out to the particular element within the array. So that's the reason why the arrays and pointers are literally kind of a single topic. So it's not about to distinguish them. But okay, so if here I just say pointer to FEN ++, you'll see that we are looping through all the available characters within our FEN string. And now the trick is to exactly match the current given position for the character within the FEN string with the specific position on our board. And in case if we encounter, so we would have three cases here. So the first case, if we have a piece available. The second case, if we have this number available. In this case, we will need to shift our variable responsible for a file just slightly bit to the right. And also, well, actually, we would be handling this kind of slashes, but that's the most easy part. So let me just try to keep going, and I hope this would be more clear along the way. So I will make use of this print statement further on, but first let me say, so we need to match pieces, and here I can say if, and here would be two conditions that that might be either left condition, or this is the or symbol, or the right condition. So here we can say if pointer to FEN, which represents the current given character within the FEN string, right over in here, so this one, and then this one, then this one, this, and so on. So every single character. So we need to match if it is actually a character. So more or equals than a, and pointer to FEN is less or equals than than z. Okay, and exactly, oh my god, sorry. And exactly the same thing for the upper cases, so big A and big Z. Okay, so yeah, this is kind of it. So in this case, we want to, well, let's print. Oh my god, did I delete my print statement? Well, I did. Well, okay, guys. So let's drop it. Just wanted to show you that. So anyway, what we need to do here, we need to set the piece on board right over in here, And the second thing to consider would be to increment FEN pointer. So gonna pick up the next element within our FEN string. So here I can say like we need to use the board, and well, before this, you remember last video we did create this character pieces array. So we can use the FEN pointer available right over in here within the parse FEN function. Like, where is this? Here, right over in here. We can use this as an index within this character pieces array to return an encoded version of a current given piece. So say we encounter this this white pawn within the FEN string, and then this would be encoded to this p, which is actually index which is equal to 1. Okay, so first or maybe I just can directly go for this. So board index by the square would be equal to, I'm referencing this character pieces indexed by the pointer to our FEN, and here I need to increment our FEN pointer, and if I did everything correctly, it now should print the 8th rank, so a couple of rooks and the king there. Okay, it didn't because I didn't yet handle the so yeah, it goes like the rook, and after we need to take care of this number. So yeah, that's the reason why it didn't print it further on. So the next thing to consider here would be to match, oh sorry, what have I done? Not here. The next thing we need to match, let's say empty squares, and here we can say if, and if the pointer to FEN or current given character within the FEN string is more or equals than the character of 0, and pointer to FEN is less than equals than pointer to 9. So you know, like this expression is just like the Python equivalent of isAlpha, and this expression is like the Python equivalent of isDigit. So just to make it a little bit more clear. So here we need to, yeah, we also need to increment the pointer, and also we need to so first we need to calculate offset. So in order to do this, so let's just create the integer value, the integer variable offset, and this would be equal to pointer to FEN minus 0. And this is a little trick. So this is the way of how to convert the character into the integer. So I'm not going to be diving that deep into explanation of how this works, but in Python you could have say like if you have like this string and you want to convert this to the integer, so you can say like or first you need to say like ord in order to convert this to the ASCII character, this like, and then so let me just try to open my console here to show you Python 3. So you would be very like, what are we doing actually? So let's consider some letter. So if we say like ord and the letter, we get the ASCII key, and if we just say minus ord and 0, it would be oh my god, in Python this is slightly bit different. I'm just wondering like oh well, that's because yeah, that's because I need to make this with integer values, obviously. Yeah, and if say we have it like this, so it's been converted to the integer value already. So this 5 is already an integer. So just to make it a little bit more clear, Okay, and as far as our offset is being calculated, the next thing to consider, we need to skip empty squares. And here we're taking care of our file variable that is representing the current file we're now iterating over, so like A, B, C, D, E, F, G, and so on. So these guys are the files, and we want just to say like plus equals offset, which is the shortcut for saying like file equals file plus offset. So that's kind of it. And the list, it kind of would almost work, but not really. So there would be needed one more extra, a couple lines of code being added. But before that, I just want to say like match end of rank, and we can say if the pointer to FEN equals to slash. In this case, well, I guess it's literally enough to say like just increment our pointer, and that's kind of it. This should be enough here. Again, it won't really give the exactly correct result, but I just want to show you one little thing. So you see, like in case when we have some squares, so just to show you how it looks like on the real deal. So let me just grab this tricky position again, copy, and if we just paste this in, okay, so it almost correct but not exactly. So you see, like the first three lines match perfectly well, but starting from this line we got a shift one square to the right, and that happens because so if we have this a square, if we have a piece on a square before we're supposed to be adding our offset, everything is going fine. But if we don't, in that case we need to decrement file by 1. So let's say like file equals file minus 1, or just file minus minus from the shortcut. So we need to match this sort of a case within matching the empty squares. And well, I guess there is no much difference where exactly to put this. So say match or decrement file on empty squares. So here we can say if and the board indexed by the square, we could have say like equals to empty, like this, so nothing there. But the shortcut for doing this, just saying like if not board square. So in this case we want to say file and minus minus, and I hold my breath and I really hope this should work for me now. Okay, does it? Yeah, it seems like. So let's check the position. So we got the rooks, okay, king, a couple of bishops, this pawns here, okay, so the black pawn here, okay. So yeah, this is quite pretty nice. So at the moment the position seems to be okay, and let's also try to try to render our start position. So yeah, we got our start position from the FEN, and let's get back now to the tricky position as well. Save. Okay, perfect. But obviously FEN is not only about setting up the pieces, but also we need to keep track of our site to move, and also castling rights and the enpassant square, which is absolutely essential. So after our board array, I would like to define a couple more variables. So site to move, and we call it simply site, and by default this would be equal to 0. I guess we would have been setting it to 1 if white is to move, and to 2 if black is to move. I guess this is just quite pretty normal. And yeah, by the way, if we don't specify the the FEN, which is a bit weird, but still we can keep this side equals to 1. Actually, I think this is just fine. Then we need to define the inpassant square, and let's define a variable called no square after the last visible kind of like stuff here. So just so to make sure that no square would be off board, so we will use this. It would be 111, 12, 13, 14, 16, 17, 18, 19, 20. I guess 121. Well, it doesn't really matter that much. The main style that it's not on the board, so this kind of the inpassant square kind of not available. So just to make sure. So by default, our inpassant square, so inpassant would be equal to no square. Okay, and castling right, castling rights, and the castling. So yeah, all these guys should be integers. And now things are getting a little bit more complicated, and I will now try to explain why exactly. So let's try to compile to make sure it still compiles and runs perfect. So we need to define one more the structure here. So we did enumerate our pieces, our squares, and also let's enumerate castling rights. And we're supposed to be using quite a pretty tricky technique in order to do this, like bitwise encoding of the castling rights. It's way easier to show rather than to explain, so let me try to do this. So let's enumerate, call this castling, and here what kind of cases we're supposed to be having. So we have this notation of big K, big Q, little k, little q. So this means that white is allowed to castle king side. This big Q says that white is also allowed to castle queen side, and this little k says that black is allowed to castle king side, and that black is allowed to castle queen side. And we will use this notation exactly just to make sure. So k would be equal to 1, and then castling queen side would be equal to 2, and then castling to the black king, castling to the king side would be equal to 4, and black black queen castling to black king castling to the queen side would be equal to 8. So I don't know where exactly to provide this. So well, let's say binary representation, or let me just to put this binary representation here. So castling binary representation. So let's consider like so in binary, so if we have 4 bits, so this would be 1, and this means that king can castle king side on that, probably, yeah, to can castle to the king side. Okay. Okay, and so this is binary. Okay, and this is decimal. Okay, so in binary, number of 2 would look like this. Okay, and here we can send that king actually white king here, white king can castle to the queen side. Okay, and here the binary representation of 3, we can say that black king can castle to the king side, and finally this is 4. Oh, I'm sorry, what have I done? This is 4 and this is 8. What have I done? Yeah, obviously. So black king can castle to the queen side. Okay, and you see, like we're using the single digit basically in order to store the right of where the current given site, where both sides can or cannot castle. And now let's consider a couple of examples. So if we have all the ones, this means that both sides can castle both directions. Okay, and yeah, like this. And say I'm really sorry for this long explanations, but this is absolutely let's pick up some random stuff. So what do we have here? We have like black king is available to castle to the queen side. So let's say just ensure black king and okay, to the queen side, right? Queen side, and then we got this white king can castle to the king side. So white king to the king side, and we would be using the bitwise operations in order to set up these numbers basically. So let me try to open my Python interpreter again, and I just want to Google one little function. So Python add trailing zeros, add trailing zeros to string. I just need us to visually demonstrate like what I mean there. Well, it's a bit. Hold on, guys. I just want to Google for this. Okay, it seems like I've just found this function. So let's get back to our Python interpreter. So I can now show you this. So let's consider this castle variable. So it would be equal to 0, right? And let's print I want the binary representation of our castle variable. I want to get rid of the first two elements, and I want to use this. How do they call this? Yeah, I guess I need to convert this to string first. So stringify this stuff. And dot L just left justify, I guess, and I need 4 characters and to fill them with a 0. Okay. Okay, so this is it. And now let's say I want to say like castle, I want to bitwise OR this with so let's think what do we want. So let's try to bitwise OR this with 1, and the result would be 1, and like this. And if we just print this castle again, sorry, let's make it here bitwise end with 1. Excuse me. Hold on, guys, just it's kind of wrong. It's putting this zeros into the wrong place. It gives the right result, but for some reason, okay, just need to figure this out a little bit. Sorry. Okay, guys, sorry, not the L-just, but R-just, or right justify. So now that this seems to be working perfectly well, if we now just bitwise order with this with 2, this would give us 0, 0, 1, 2. Okay, if we bitwise end with the 4, it would give us 0, 1, 0, 0. Okay, and finally, if we bitwise end with all this with the 8, it would give 1, 0, 0, 0. But here in this versions, the castle only is only being bitwise ordered with the only single castle in right. But what if we want to make it to bitwise order this with multiple options? So I'm not sure if this is syntactically correct what I'm supposed to be doing now. Okay, sorry guys, just been a little bit distracted. So probably let's try to enclose this expression within the parentheses to make sure it would actually work properly. So with 8 and with 2, so now the very first and the very last digits should be switched to ones instead of zeros. Yeah, perfect. And say we have this like 4 and 2. Now the these two would be ones, and the those two will be zeros. Okay, so I hope this is kind of quite pretty clear. Like, how do we setting up our castling rights variable via the bitwise operations? And this is exactly the stuff that we're supposed to be doing within our parse FEN function, believe it or not. So that's the reason why I'm explaining you this so much. And later on, when we would be printing this castling variable to the along with the print board function, would be doing the opposite operation of not bitwise ordering or setting the bits, but bitwise ending, or like just trying to retrieve the bits from kind of this variable to understand like which castling rights are actually available. So for now, we'll just drop this terminal and go back to my main one. And well, I hope that the explanations regarding the king castling regarding the castling rights should be quite pretty clear here. Okay, so I'm not sure if I should actually keep this. Well, probably I will. So let's get back to our parse FEN function, and so we just went off the loop. So I guess where is this happening? So this is the if statement, and is this gonna be right over in here? So I just want to print printf and pointer to FEN++. Sorry guys, I just want to check this on my own first, and then I would be explaining if this works. So character, it should give me a little W now standing for the white pieces. Oh my god, what's kind of wrong here? Redeclaration of the enumerator. Oh, so this is, yeah, this is a little pitfall here. So I've already used my this king queen upper and lower cases in order to represent to encode our pieces. So yeah, okay, so probably we can just change the variable names for this encoding. So let's say king castling, queen castling, king castling, and queen castling, like this. So I think this should work. Okay, and why I can't see Okay, so where is our parse FEN function? So let me try to make it to print this as a string, so to see what the string is kind of left out there. So to make sure that I'm doing this outside loop already, oh my god, but you kidding me? Oh, I need to say the FEN like this, I guess. Well, so here is, oh, probably, yeah, okay, so here I need to increment FEN pointer again to go to parsing the site to move, and I can simply say like pointer to FEN ++, and now I can already print my pointer to FEN, and this should give us this this little W letter. Okay, so perfect. So the site to move is always available, and this is just a pretty important thing to consider. And just hold on, guys. Okay, it's just so many material, so much material left, but this video is lasting too long already, but nevertheless. So the next thing to consider, we need to parse site to move. So let's ask, so I'm gonna use just forgot how to call this, well, some sort of a shortcut for the if condition. So we can say like pointer to FEN equals to this W. So if this is true, in this case we need to set up site equals to so let's also enumerate the sites. So, and I'm canceling and sites to move. So in let's call this sites, and this would be, well, I guess we can use it white on black. So yeah, in this case site should be equal to 0. That stands for white. Yeah, maybe we should also add like no site. Well, yeah, let's actually do this as well. No site. This might not be necessarily needed, but for some point I just want to make it like this. And actually let's initialize this to, hold on a sec, no, let's initialize this still to the white. Okay, it doesn't really matter that much, but yeah, just, or, well, I don't really remember how it's better to be done. There are different patterns regarding this site enumeration. Site equals to white. Okay, so here let's say site equals to white, and otherwise site equals to black. So let's say this is gonna compile and run basically, so I don't need the browser anymore, I guess. Okay. Excuse me. So some syntax error. Hold on, guys. Oh, I'm sorry. I completely forgot the C syntax, so we don't really need to use this site anymore. Just white or black like this. Okay. 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 So now it's already time to start updating our print board function, because otherwise it would be hard to see like if the updates are about to come here or not. So here within the print board, after, so let's say print board statistics, stats, and we can printf side to move, and let's give it a string and the new line after, and we can say we can ask again like side equals to white. In this case we want to say white, otherwise black. Well, I'm not sure this is syntactically correct, but let me try. Okay, perfect, we got this side to move white. Save. Okay. Well, actually side would be literally enough here, and then let's consider the canceling, I guess, right? So printf and canceling. So first I will be making this as a decimal just to debug the encoding itself, and later on when the encoding is I'm sure that it is fine, I would be actually prettifying this back to this king queen stuff like that. Okay, so what castle undeclared, didn't I well, actually not castling but castle, and by default, well, actually it should be 15, because if you bitwise and with all the bits it would be like all the ones in binary, and in decimal it would be 15. So I'm not really sure. 0. So yeah, the problem is whether it is intended to use this board representation like we initially supposed to. Yeah, let's make it to 15 basically. So I will say decimal 15 would be like 1111 in binary. Which means both sides castles to both kings can castle to both sides. Okay, even though I'm not gonna be using this without the parse FEN anyway, but still, just to make it a little bit more clear. So now this should print this castle equals to 15. Okay, but hold on a sec. I mean, like, yeah, I need to reset this variable during the within the reset board. So yeah, reset board, and here reset stats. So side, let's make it -1, and castle, let's make it 0, and enpassant, let's make it, well, it's still no square, but yeah, this should work. Okay, and if we just run this again, now we got this white this side is equal to black. Is this actually equal to black? I'm wondering really. So no, it's white to move. Then why on earth do we have this side equals to black? Okay, parse FEN. Yeah, I guess I need to say side equals. Yeah, now it's white, perfect. And castling is not available. Okay. I will be debugging every single line here, so no worries. For now, just want to add a new line here. Save. Okay, and okay, let's just try to grab some custom. Let's try to grab some custom. Well, to grab in the tricky position, but using some custom castling rights and the site. So if I just convert this to black, we got black. If I convert this back to white, we got white. Okay, and okay, so the castling is 0. Okay, now I want to parse castling. But before that, I just want to print what's still left there within. So we need to make it plus equals 2. So increment. So let's say like go to site parsing, and here go to castling rights parsing. Okay, so FEN plus equals 2. Okay, let's have a look again. So, oh my god, you're kidding me, man. How is this? How is this possible? So why is this giving me this segmentation fall? Is this because of? This is so weird. Come on. If I just plus equal 1, why I can't do this? This is incredibly strange. This is incredibly strange. Why I can't do this? Oh, in order to, so yeah, I need to say FEN plus equals 2 like this. Okay, yeah, so I can increment. Well, it's really hard to explain here, but if you want to increment more than one character to FEN, you need to use the pointer to string rather than pointer to the character. It's hard to explain, but just let's drop it like as it is. So from now on we can move on. We can loop over the next characters until we encounter an empty space. So here I can say like parse castling rights, parse castling rights, and I can say while pointer to FEN is equal or is not equal to empty space. We want to increment pointer, so pointer to FEN plus plus, and let's just try to print what we have there along the way. Save, but the character and pointer to FEN. Okay, so we match exactly this guy. So now this means that from now on we can actually switch our pointer to FEN and match some cases. So case king, and we'll handle this just right in a moment. And copy, paste, and the very last case, like nothing there. Maybe I could have used default here, I'm not sure, but I will just use case. So coincide, black, coincide black. So here I want to say castle variable bitwise OR with kin castling, right? So bitwise OR with 1. Yeah, here with the queen castling or bitwise OR with 2, and here black king castling bitwise OR with 4, and here white king castling bitwise OR with 8. Okay, queen castling, and here here I just break, right? Also I want to break after every single, I'm not sure, maybe these breaks are not really needed, but just to make sure it works I will just add them. So I'm wondering if I'm setting this castle to 0. Okay, so it now should give the castle equals to 15. What? Queen castling. Oh, not like this. Like this, queen castling. It's not getting equal to 15. Because I need to say castle bitwise OR equals. So it's the shortcut for say like castle equals castle bitwise OR with king castling, queen castling for whites, for blacks, and so on. Okay, now we got this castle equals to 15. And now when I would be changing these variables, the data would be different. So if I just drop this one, it should be like 0, 1, 1, 1, which is 7. So it should now give me 7. Why it gives me 14? Oh, because it's opposite from the opposite direction. Yeah. So 10 is the very first one. So it would give me 7 now. Yeah. Okay. So it seems like it kind of works. So in this case it would give me 1. In this case it would give me 2. Okay. And say if I say black castle king side and queen side, so it would be 8 and so this would be 1 1 1 0 0, so 8, so it would be 12. Okay, yeah, perfect. So yeah, it seems like it works quite pretty nicely. And okay, one more thing. So here castle equals to 0, yeah, which is fine. So let's get it back to king side, queen side, king side, queen side, save. And now just in order to avoid this guess the number game, I would rather implement this bitwise ending logic within the print word function. So I want to print f. Oh, not here. Sorry, not here. Oh my god, let me remember how I done this before. So okay, just hold on a sec. Okay guys, so that's how this is done basically. So we have 1, 2, 3, 4 characters for our. So how can we go to the next string and see? I'm wondering, this like or this like. Okay, we'll see this just right in a moment. Okay, so we need to ask if castle would be bitwise ORed this time, bitwise ended this time with a king. So first we go for king castling, right? King castling. So if this equals to true, I want to print the key, k, otherwise print dash stands for nothing there available. And I just want to copy this. There should be some way of how I can. So this would give me an error, I guess. Just let me recall my memory how this is done in C. Okay. Yeah, this should give an error. Oh, it does. It doesn't. Whoa. Whoa, this is pretty nice. Okay. Okay. So here, Queen side castling and Queen. Here, black king castling king side, and this like Queen side. Okay. Okay, so it seems like it has been parsed successfully. So now let's try to play around. So now if I would be changing this castling rights, it should have been changed accordingly. Yeah, you see like the here in the initial FEN we don't have white king queen side castling right, and that's the reason for instead of printing this big Q, he just gives the slash for us. Okay, and say let's get rid of this black king to queen side castling, and it should replace this Q with a dash. Okay, and if we just get rid of them completely, in this case we have no castling rights. If we just say we have only black king can castle to queen side, it would make this one equals to K. Okay, perfect. So let's drop it back. So king side, queen side, king side, queen side. You know, I guess this routine stuff is it might seem really boring, but this is incredibly important. And when I initially wanted to actually start this chess programming channel for about 1 year ago, I really failed because I couldn't. I did copy paste this. I didn't really understand this much, but I really didn't want to dive deeply into this. But now it's incredibly interesting for me, even though it seems like I've been doing this really lots of times. Okay, so let's go for the very last but not least. Then so we need to parse our enpassant square. So well, okay, so let's try to go for this. So first let's try to match the data regards to our enpassant square. So we just print f and let's make it a string and FEN. So to make sure where exactly we are at the moment, so we need to make one increment there. So go to enpassant square. Okay, and pointer to FEN plus plus. And now we want to parse enpassant square. So we need to say if pointer to FEN if pointer to FEN. Okay, just edit the layout slightly bit there. So if it's not equal to dash, in this case we want to provide our logic, so we don't need this stuff anymore, I guess. And I guess else and it would be equal to no square, I guess. Yeah, so enpassant equals to no square. Save. So this is gonna work. Okay, and also we want to print our enpassant square, and we'll make use of this square to coordinates, or maybe no, not that, like it's a bit more complicated. Just hold on guys, just let me, okay, print f and enpassant, and this would be equal to, well, first let's make it a decimal, so enpassant, so for now on it would be printing like 120, yeah, which stands for kind of not available. Okay, also just to prettify this stuff a bit, I just want to do one little trick which would increase the readability significantly. So black, is this the same? B-L-A-C-K, yeah, it's the same. Okay, and enpassant would be always two characters when we will translate this to convert this to the coordinates. So yeah, it should be this like. Okay, enpassant square. Okay, now we need to parse. We need to parse enpassant square z file and rank, and int file would be equal to we can reference FEN by 0, which is the current pointer to FEN. So we can write this like, or we can write this like, they are literally the same. And minus a, so this trick is quite pretty similar to the converting from string to integer. I'll try now to explain this a little bit more. And integer file would be equal FEN1, which is the next character after this one, minus 0. And this is already quite pretty known. So now let's try to print f. So this would be the file, and this would be the rank. Okay, file and rank, save. So now it won't print anything really because it's not available, and also I'm getting some errors. Yeah, here rank. But if we try to specify, like, I don't know, E3, let's say, it gives us this kind of rank equals to 4, 1, 2, 3, it's not exactly, and yeah, I need to adjust this slightly a bit, but okay. I'm just trying to extract the coordinates that later on would be converted to the given square using the formula that we have been using before, like rank multiplied by 16 and plus file. But first we need to match these coordinates exactly. So the file is 1, 2, 3, 4. Well, I guess I need to say maybe like +1 here. +1. I'm not sure, but probably I should. 5 and 4. Okay. Yeah, it seems like. And square. Now we need to match the square. So set up enpassant square. So enpassant would be equal to rank multiplied by 16 plus file. So our regular expression to actually calculate the given square using the coordinates, file and rank coordinates. Okay, now it gives this 69, and now we can already convert this 69 into how I call this, square to coordinates. Yeah, so I can say square to coordinates and the enpassant square, and this should be E4. My god, oh sorry, it's the array, so we need to index this using this enpassant variable. Oh my god, what's going on here? Oh, that's because I need to convert this to the string. F4. Well, this is a bit tricky. Why is this F4? Oh, what have I done? Why do I consider this to be E4? It's E3. Yeah, so this was completely right. So what have I done? Oh my god. So we don't need this stuff. Obviously, I thought I'm referencing the enpassant is E4. Yeah, E3. Oh my god, now it's E5. So probably in this case we need to say rank minus in this expression, right? This should be. Okay, calm down, Komaki King, calm down. Calm down. Debug this calmly. Okay, E5. Well, on the real deal, this is E3. Okay, if I say this to be like, okay, A1. So what will you tell me? Okay, consider this to be like A7, right? So the first part seems to be working, so now we'll give H7, right? Okay, so the files are matched perfectly well, while the ranks, I'm just wondering why I can't. Did I say 8 minus or 7 minus? I guess I should say 7 minus, not 8 minus. You kidding me, man? Come on. Oh my god. Or maybe I'm not really good at math. Sorry for this, but I'm just wondering how on earth can I trial and error method. Okay, let's start from the very beginning again. What? You kidding me, man? Okay, sorry guys, I need to figure out what's going on here. Okay guys, so the trial and error method showed me that we'd actually need to do almost like what I'm supposed to do. So 8 minus and this sort of an expression, not 7 because it starts from 1, not from 0 within it's the kind of coordinate notation, not the array notation. And so we have this, say A8, and let's try to have a look. We got this A8. Now let's try to A1, save. We got this A1. Let's try E3, save. Got E3, E2. Okay, say, I don't know, G5. Okay, so you see, like, now our enpassant square parsing is being completed and works quite pretty nicely. So well, probably I can add one more little feature here to prettify the print board stuff slightly a bit. If I can just make something like this. And I know this is already kind of weird, but still. Yeah, so probably this is gonna be a bit better. I just try to replace this with Okay, so probably this. Sorry guys, just try to apply my design skills to purify this stuff slightly bit. So eventually we did manage to parse the entire FEN. So the board position, then the side to move, then the castling rights, and finally the enpassant square, if any available. And this is quite pretty important function so far, and I really hope this is bug free. If any bugs would occur during the development process, I will definitely let you know this and fix them as well. I'm really sorry for this video is lasting kind of too long, but again, like, I really needed to explain all this castling bit stuff and actually literally all the stuff that I've already been explaining. So I'm not really sure regarding what in particular was supposed to be implemented in the next video, because again, like, I didn't yet write this engine. Obviously I did write lots of chess engines in my life, and I referenced the source code that I've written before, but this one is kind of new, and it didn't really write exactly this like chess engine before, so I'm kind of writing this from scratch. So the way I go, just try to write the next piece of code and try to debug this and then make it a video, and it's not always happens that the very first attempt is going to be successful to record that. Well, anyway, we did set up quite pretty lots of basic stuff. Probably we'll definitely add a bit more data structures here, probably. Well, maybe, well, we'll see. But anyway, it's already quite pretty solid basis in order to start actually developing the move generator, but probably before the move generator we would be implementing the is square attack function that would be answering the question whether the current given square on the board is attacked by a given side or not. So probably that would be the next thing to consider. I don't promise though, so we'll see. Anyway, thanks for watching, guys. I really appreciate you watching these videos and supporting me. I want to thank all those guys who came here from my main Code Monkey Kings channel. So I really appreciate you watching this, and if you try this at home, this would be just absolutely fantastic. So thank you, guys. I mean, really, this is really important for me. So this is it from my side. Until the next video next time. So take care.